I feel so good welcoming you, dear friends, to our last section of division and, of course, the last part of basic arithmetics. Word problem leading to division. We are going to conclude basic arithmetics with this last section of division, word problems leading to division. In our last video lesson, when I concluded division of numbers by decimal numbers, I told you to prepare for this class and I encouraged you to watch the video lesson on word problems leading to multiplication. The reason that the secrets I taught you under word problems leading to multiplication are much of the secrets you need when handling word problems leading to division. Please follow along these secrets as they display on the board. The secrets you need, the principles, the guidelines when dealing with word problems leading to division. As a matter of fact, secret number 1. You need to remember all the secrets that are used in dealing with word problems leading to multiplication. That is secret number 1. And when I taught you word problems leading to multiplication, what were the things that I pointed to? You remember, first of all, I told you that it's important for you to be able to identify the two major information that the question you are solving is interested in. And I told you that it's also important for you to possibly select a letter to represent the unknown. So these secrets are very important when dealing with word problems leading to division. Secret number 2. You should have a knowledge of dividing both sides by the coefficient of the unknown. Wow, this secret number 2 is very important because we are going to meet that under simple equations as well too. You need a good knowledge of dividing both sides by the coefficient of the unknown. What do we mean by coefficient of an unknown? The coefficient of an unknown, just like you may have learned from our quantitative reasoning class, is simply the number or the things multiplying the unknown, multiplying what you are looking for. So you see, whenever you're dealing with word problems leading to division, you will always get this coefficient of the unknown. So if you are now trying to calculate, get the value of the unknown, you are expected to divide both sides of the equation by the coefficient of the unknown, by the number multiplying the letter that is selected to represent the unknown. I'm going to give you a quick example to help you understand this. Please take a look at the screen once again. And then if I give you something like this, say 2 equal to 6. 2 equal to 6. 1 equal to x. You know, x is the unknown. When you have such arrangement, you cross multiply. You still remember how we did that under multiplication, right? What problems leading to multiplication? That's why I told you need that knowledge. So we don't waste time as we are learning this word problem leading to division. 2 equal to 6, 1 equal to x. The next thing is to cross multiply, is that not so? If you cross multiply that, you can see 2 will multiply x to give us 2x equal to 1 will multiply 6 to give us 6. So this gives us 2x equal to 6. And if I give you 2x equal to 6, that 2x is simply 2 times x. So 2x equal to 6 is the same as 2 times x equal to 6. Now you are looking for x. What is the coefficient of that unknown x? The coefficient of that unknown is the 2 that is multiplying that x. Therefore, you are going to have 2x divided by 2 equal to 6 divided by 2. Coming to the part of the 2x divided by 2, that 2 will divide itself to give you 1. So you have 1 times x, which is x, the unknown that you're looking for. Then you now look at the right hand side of the equation. 6 divided by 2 will give you what? 3. That simply tells us that x, which is our unknown, is equal to what? 3. So what's the point? That secret number 2 is telling us to know how to carry out dividing both sides by the coefficient of the unknown. Having reminded you of this secret we learned under word problems leading to multiplication, and of course introduced a new secret you need as we move on into word problems leading to division, I present to you our very first question, number 1. A tiler requires 4,056 ties to tie a shop. If there are 39 ties in a carton, how many cartons will he buy from a tie seller? In our houses, we have ties, right? Okay, this tiler requires this number of ties, 4,056 to tie a shop. Now he wants to go and buy these ties. Of course, you know that these ties, alright, they come in cartons according to the question, and there are 39 ties in a carton. The question now is, how many cartons will this tiler buy? Will the tiler go to a tie seller and then tell them, I need 4,056 ties? So they start counting the ties one after the other. No, 1, 2, 3, 4, till they get to 4,056. Of course, that's not possible. If we know the number of ties in a carton, the tiler can just, calculate the number of cartons that will give him 4,056 ties. And that is why you need all this knowledge of basic arithmetics. I have always said this from the beginning of part 1 of basic arithmetics, which is addition, that we do all of these things, in our daily lives. So coming to this problem now, leading to division, let's find out how we do that. From the question, we need to determine the two information. We need to find out the two information, the two parameters, the two data of interest to us. And how I will get to know this is, quickly I'll go to the part where they asked me, how many cartons will he buy from a tie seller? How many cartons? So I know that I am looking for the number of cartons. The number of cartons that the tiler will buy. And of course, I will write, let the number of cartons that the tiler will buy from the tie seller be equal to, I want to use X for that. Alright, so from here, one of the things of interest that the question requires is for us to know, alright, the number of cartons. So we've gotten one information, number of cartons. And from this question, you see that they gave us values on number of ties. We have 4,056 ties, we have 39 ties. So definitely the question is also interested in ties. Now, I've gotten the second information, ties, number of ties. So I think generally this question is interested in number of cartons and number of what? Ties. Now let us go back to the question. If there are 39 ties in a carton, when I taught you word problem leading to multiplication, I told you the use of words like a, and, h, per. They all refer to what? One. They mean one. So from this problem, I can arrange the two information of interest. Here I can just put, let me say cartons here, alright? Cartons. And this side, let me put number of ties. Good. So from the question, I know that there are 39 ties in a carton. So I'll just write 1 carton equal to 39 ties. Now, if 1 carton is equal to 39 ties, how many cartons will contain 4,056 ties? So I'll come here and then put X, which is the number of cartons the tiler is going to buy. X, how many cartons will give that tiler 4,056 ties? So my problem now is to get the number of cartons. Here the ties will go off, cancel them. That's why I told you, you need to remember all you learned under the secret of word problems leading to multiplication. From here we are going to cross multiply, you know that? So let us do that. X times 39 will give us 39x. 39x equal to 1 times 4056, which is the same as 4056 times 1 carton. Alright? 1 carton. And of course, if you look at this, 4056 times 1 will give us 4056. So that this is simply 39x equal to 4056 cartons. Anything we get here will be the number of cartons. Take a look at this. 39x equal to 4056. This is the same as 39 times x. Now to get our x, what do we do? If you multiply any two things to get a particular answer, now that answer divided by any one of the two things you multiplied will give you the other one. I am multiplying 39 by x here to get 4056 as the answer. So 4056 divided by x will give me 39. And 4056 divided by 39 will give me x. Now I don't know x, that's what I'm looking for. So I'm making it to stand alone. It means I will do 4056 divided by 39 to get x. So here I'll write DBS. I'm sorry that I have to abbreviate. DBS means divide both sides by the coefficient of the unknown, which is 39. Now I am going to divide both sides by 39, and so I will rewrite this 39x divided by 39. Of course, that 39x divided by 39 will still give you x alone. This is divided by 39. Can simply bring down my x to be equal to 4056 divided by 39, then I'll solve straight. Anyway, you know, for every first question I solve, I take my time to show you all the things you need. As we move on, I would avoid some of the unnecessary things. Okay, this 39 will divide this 39 to give us 1, 1, and you know, 1 times x divided by 1. You know, 1 times x divided by 1 will still give you x. So I'll bring down my x here. This is x equal to, I'll come over here and divide. So I have 4056 to be divided by 39. So this is where my division comes in. Let's be fast in doing that. 4 divided by 39 is 0 remainder 4. Attach the 4 to this 0. And so you have 40 divided by 39 will give you 1 time, you know, 1 remainder 1. Attach the 1 to this 5 and you get 15. 15 divided by 39, small number divided by bigger number is 0 remainder the small number. So this is 0 remainder 15. Attach the 15 to this 6. You get 156. That 156, let us divide it by 39 and see. Okay, so we watch on this and see 156 divided by 39. If I go, let's say 3 times 39. If I say 156 divided by 39 is 3 times. 3 times 39 will give me, okay, 27, 7 carry 2, 39, so that is 100 and I think 17. So I'll try 4 times. If you check 4 times, alright, 4 times 39 will give you what? 4 times 9 is 36. Write 6, carry 3. 4 times 3 will give you 12. Plus the 3 you carried will give you 15. So I think this will be 4 times exactly. Yes, 4 times. I've always told you how important your multiplication is to help you out in your division. There is no remainder. 156 divided by 39. In 39 times 3, if you check the multiplication, it is 4 times exactly. So x is equal to 104 exactly. You know, when that is the case, if the denominator divides the numerator completely without remainder, you will divide the denominator by itself. So 39 divided by 39 is 1. So my answer here, 0104, is the same as 104. That is 104. You know, this first 0 does not mean anything, just forget it. And that's the number of cartons that the tiler needs. I can make my conclusion now. Therefore, the number of cartons that the tiler will buy from the tile seller, which we say should be equal to x. That x, we have found the value to be 104. Therefore, the tiler needs 104 cartons of the tile. We are done with this solution to question number 1, and I will encourage you to rewatch it before you move on with me as I solve question number 2. Remember what we did? Simple. Get the two information of interest. You want to do the arrangement? Yes, you arrange it, cross multiply. Of course, the unknown, you must have selected a letter for it. And once you cross multiply, one thing that makes a difference between what problem leading to division and what problem leading to multiplication is this. When you are doing your cross multiplication for that of division, the unknown will multiply a number which is not 1, is greater than 1. In most cases, are you following, right? Okay, a number which is not 1. That is what we see in what problem leading to division. But if you take your mind back to what problem leading to multiplication, the unknown, if you do the arrangement, the unknown will always multiply 1. And the number times 1 will still give you that number alone. So you don't need anything like divide both sides by coefficient of the unknown, like we did for this division. Let's move on to question number 2. In this question number 2, we have that a crate of egg contains 30 eggs. If Sumto's bus carries 15,960 eggs, find the number of crates in Sumto's bus. I love this question. Do you know why? If you take your mind back to our video lesson on what problems leading to multiplication, you can go up, scroll up in the Telegram channel to check for this particular question, or you can go through your notes and see. Question number 1, under what problems leading to multiplication? That question is almost the same as this. Does that mean that this problem is going to be solved using multiplication? That is why I told you that it's very important when dealing with word problems, maybe leading to multiplication or leading to division, getting to know the two information of interest and setting out your arrangements is very important. Alright, because sometimes if you want to go directly, depending on your level of understanding, you may mistake a multiplication problem for division problem, or a division problem for multiplication problem. But when you set out your arrangement, you would actually know what to do. I will be fast in solving this question, alright? We are told that a crate of egg contains 30 eggs. If Sumto's bus carries 15,960 eggs, find the number of crates in Sumto's bus. So how do I get to know the two information of interest here? If you quickly come to this part where the main question is based, find the number of crates in Sumto's bus. It means that the question is interested in the number of crates. Therefore, that is one information I need here. And I would, select a letter to represent that unknown. Let's say, let the number of crates in Sumto's bus be equal to y. Now, how do I get the second information of interest? A crate of egg contains 30 eggs. They gave us a value of eggs here. In fact, if you even move on, they still give us value of eggs again. That simply tells us that number of eggs is also our interest in this problem. Therefore, the two major information of interest, the two parameters, the two data of interest in this question, number of crates and number of eggs. So I can put my eggs here, and I can decide to write crates here, alright? Crate of the eggs. And from the question, we know that a crate of egg contains 30 eggs. A crate of egg. A crate means 1. So under this crate, I'll put 1. Are you following, right? 1 crate. And we are told that it contains how many eggs? 30 eggs. I'll come under this eggs and put 30 eggs there. Alright, this is equal to. Then moving on, if Sumto's bus carries 15,960 eggs, find the number of crates in Sumto's bus. So we have 15,960 eggs. This will now be equal to how many crates will contain this number of eggs in Sumto's bus? We don't know. And we selected y for it. So we are done with our arrangement. If you see this thing clearly, look at your cross multiplication. You will notice that y will multiply 30. Y did not multiply 1 if you are to do the cross multiplication. Y will multiply 30, telling you that this is a division problem because you divide by the coefficient of the unknown, which is 30. In fact, from here, I know directly that to get the number of crates in Sumto's bus, since the coefficient of y there will be 30, it simply means I'm going to divide 15,960 by 30 to get the number of crates in Sumto's bus. Anyway, let's move on. This x we cancel out. So when you cross multiply, you have 30 times y, 30y, and that will be equal to 15,960 times 1, which will give you 15,960 crates. 15,960 crates. Good. So from here, we are going to divide both sides by the coefficient of the unknown. Let me just write dbs by 30. We already know the coefficient of the unknown is 30. Now watch, because I don't want to write 30y divided by 30 anymore. Look at this. If you write 30y divided by 30, that 30 will cancel out, y will be left. So why not I bring down my y directly? So I'm going to have y equal to, then I'll come to this side and write 15,960 divided by 30. Is that okay? 15,960 divided by 30. So from here, I'm going to cancel out these last zeros, you know. We've done this type of division before. If the last digit of the numerator is 0, and the denominator also ends in the last digit 0, you can cancel out last digits. Are you following, right? So we now move on. From here, we are going to have 1 divided by 3 is 0, remainder 1. Attach the 1 to this 5. You get 15. 15 divided by 3 is 5. 5 whole times, no remainder. 9 divided by 3, all right, will give you 3. And then 6 divided by 3 will give you 2. This tells us clearly that our answer is 532 crates. We can now conclude. Remember, this y that we've gotten to be 532. Already we said that y should be the number of crates in Sunto's bus. Therefore, the number of crates in Sunto's bus, which we use y to represent, is simply equal to 532 crates. I'll conclude. And this is how we solve this problem. We are going to take possibly 2 more questions, and we will be very fast in solving them to get our answer. I wouldn't take much time talking much, you know, like I did in question 1 and 2. And now we are going to look at question number 3. It reads, in a school, each class contains 18 pupils. If the total number of pupils in the school is 450, GMAETS41 wants you to find out how many classes the school has. Very simple question. I'll go straight to solving it. No time to waste. The 2 information of interest here are, we are asked to find out the number of classes, that is how many classes the school has. It means that this question is interested in the number of classes. And that is information number 1. The question is taken from here mainly, how many classes does the school have? That's the main thing here. I can say let the unknown, let the number of classes be equal to, let's say, okay, C. Now that I've selected an unknown for the number of classes in the school, the rest is stories. I'm going to go straight on to my arrangement after finding out the second information. And clearly, the second information, you can see there is about number of pupils, because it gave us the values of number of pupils. Okay, so going by the arrangement, all right, I am going to put maybe number of classes here and number of pupils here. Are you following? I have from the question that each class contains 18 pupils. Each class means one class equal to 18 pupils. One class equal to 18 pupils, all right? And so we are told that the total number of pupils in the school is 450. So in this 450, how many classes will contain this total number of pupils? Because the number of classes that the school will have in total is what will contain this total number of pupils. So I'm going to write C classes here, all right? C classes equal to 450 pupils. And so from here, cancel out whatever I want to cancel. Okay, this C, no need of putting classes here because that is the unknown I'm looking for. Simply C equal to 450. If you cross multiply this, you will see clearly that the coefficient of the unknown will be this 18. Is that not so? Cancel off the pupils there. Therefore, C is simply 450 divided by that 18. 450 divided by 18. So let us do this calculation and see. 4 divided by 18, what are we going to get? 0 remainder 4. Attach a 4 to this 5, you get 45. 45 divided by 18, let's find out how many times. Are you there? If I go say maybe, let's say 3 times. 3 times will give us what? 3 times 8 is 24, right? 4 carry 2. Of course, that's going to go to 54. So we're going to come down to 2 times. 2 times 18 will give us 36. Alright, so I guess we'll go for that. Which means 45 divided by 18 is going to be 2 times. I will indicate it 2 whole times, but there will still be remainder. How do you get the remainder? The remainder using remainder formula is simply 45 minus these 2 times 18, which is simply 45 minus 36. If you do 45 minus 36, what will you get? 45 minus 36 is going to give us 9. So you attach the 9 to this 0. Alright? That gives us 90. 90 divided by 18. What's going to be the value? 90 divided by 18 is 5. Alright? If you work it out, it's 5 times. 90 divided by 18 will be 5. 5 whole times, no remainder. So this is simply equal to 25. Since the denominator divided the numerator without remainder, we're going to have 18 divided by 18 giving us 1. Does that make sense? Alright, so we move on. Therefore, the number of classes in the school is simply 25 classes. So there are 25 classes in the school, and of course, if each class contains 18 pupils, it means that we need 25 classes altogether to contain the 450 pupils that the school has in total. Let's move on to the last question under word problem leading to division, which of course will mark the end of Basic Arithmetics Part 4, division for us. Question number 4. Our very last question, number 4. There are 100 centimeter, this cm represents centimeter, per meter. How many meters are there in 250 centimeter? So you see, according to the question, we know that there are 100 centimeter in 1 meter. That's the meaning of per meter. I told you when I was treating the secrets that we need when handling word problem leading to multiplication, the word per means for one value. Are you getting me right? Now, every 100 centimeter is equal to 1 meter. That's the main thing here. I'm going straight to solve this question. Are you following? We'll not even write let the number of meters in 250 centimeter be equal to x. I won't do that. I want to believe that by now you know the direction we take. Already from this question we are asked, how many meters are there in 250 centimeters? How many meters? So one information of interest to us is the number of meters. So what again is of interest to us? If you look at it, they gave us the value of centimeter, the value of centimeter. So clearly the two information of interest, number of centimeters and number of what? Meters. So let us go. We know that in 1 meter we have 100 centimeters. Because we are told that there are 100 centimeters per meter. So I'll simply write 1 meter equals 100 centimeters. Now, how many meters are there in 250 centimeters? I can decide to say let the number of meters be, you can say x, y, t or whatever. Are you following, right? So let me use x. So x meters, we don't know, will be equal to 250 centimeters. Of course, you're going to cancel off and cross multiply. If you cross multiply, you would see clearly that the coefficient of the unknown will be 100. 100. 100. That will be the coefficient of the unknown, which simply means we are going to divide both sides by 100 to get our x, which is the number of meters in 250 centimeters. So what does that tell you? This question is simply to divide this 250 by 100 to get your answer. I think you can do the cross multiplication and DBS on your own. I'm going straight. X here will be equal to 250 divided by 100. And of course, working on this, 250 ends with 0 as its last digit, 100 ends with 0 as its last digit. So I will cancel this last 0 and cancel this last 0. That gives me 25 over 10. 25 over 10. And how do we get 25 over 10? It's simple. Alright? You can work it out. 25 divided by 10. First, 2 divided by 1, or 2 divided by 10 will give us 0 remainder 2. Attach the 2 here, 25. 25 divided by 10 would give us 2. Are you following, right? And that 2, what will be our remainder? Because it is not whole number of times. So that will give us remainder 5. Therefore, this is simply 2 whole number, 5 over 10. The last remainder is 5. So we divide it by what? Our denominator, which is 10. And of course, 5 over 10 can still be reduced. If you want to put your answer in, let's say mixed fraction or decimal, the choice is yours. We can rework on this. Let me divide this. This 5 here, I can reduce it. 5 here 1, 5 here 2. So this is the same as 2 whole number, 1 over 2. 1 over 2 meters. That simply tells us that in 250 centimeter, we have 2 whole number, 1 over 2 meters. Does that make sense? Or we can put this in decimal. And to work it out in decimal, this will give us 2.1 over 2. Because you have introduced points here, you must attach 0 to this. Is that not so? So we now have 10 divided by 2. 10 here to be divided by what? 2. 2 can divide 10 how many times? 5 whole times, no remainder. And because there is no remainder, I will divide this 2 by itself to get 1. So this is my decimal digit value. Because it's exactly, this tells me that 2 whole number 1 over 2 is the same as 2.5 meters. So we can leave our answer either as this or as this. Can I conclude now? We are asked to find how many meters are there in 250 centimeters. Therefore, there are 2 whole number 1 over 2 meters or 2.5 meters in 250 centimeters. Please take note that this M I wrote here is the abbreviation of the unit which we call meters. Are you following? Just like this cm is for centimeter, M is for meters. I'm really very happy. And I want to believe that you too enjoyed all you've learned under basic arithmetics from part 1 to part 4. And in this part 4 division, we spent some good times on it because we broke it down into 5 different sections. And here we are done with the last section of division. If you have any question, please feel free to send your questions across. However, you can still go back to the video lessons, rewatch them, go through your notes. Maybe the question you have, the answer is there looking at you. If you think you understand all that you've been taught so far, below this video lesson, you have the lesson notes, and below the lesson notes, you have your quiz as usual. 10 questions, alright? Take the quiz, and of course, your target score is 10 over 10. In our next class, I'll be introducing you to board maths. Very important aspect of mathematics as well too. Now that we have finished everything about basic arithmetics from part 1 to part 4, addition, subtraction, multiplication, division, you should be able to solve problems that combines these basic arithmetics together. Are you following? Let's assume I give you 2.5 minus 3 plus 7 times 9, open brackets, 3 minus 1, of 7. You can just mix up numbers with different operations. How do you handle such problems? Board maths will teach you that. And I refer to that next topic I'm going to teach you, which is board maths as the brain ordering ability of mathematics. Because board maths actually help us to be ordered in the way we do things. And so it arranges our brain. It orders our brain. Get ready for that class, and please, as I welcome you into board maths in our next class, I'll appreciate if you take your time to rewatch the video lessons or studied a note on all you have learned under basic arithmetics. Let me tell you this, as long as I am concerned, we are done with mathematics. Mathematics now is simply 1 plus 1. Yes, because the two major secret foundations you need, one, numbers and numeration, where we treated things about place values a lot, and secondly, basic arithmetics, we are done with them. Every other things we meet in mathematics will still link us back to these things, right? And therefore, take these secret foundations seriously as I introduce you next in our class to board maths. Take good care of yourself.